in this modern age, we come out with new technologies and new innovations almost every day. And with these new innovations, they can improve our daily lives tremendously. Now, sometimes these innovations can cause a lot of good, and sometimes they can cause a lot of bad. And sometimes these bad things can outweigh the good things. And that is what I think about CRISPR. Now, what CRISPR is that you can put a DNA strand inside an enzyme, so this green right here is an enzyme, and it'll have a matching DNA set, and it'll go and find that DNA inside an embryo, and it will splice it and then replace it. So let's say an embryo was going to have muscular dystrophy, you could put a DNA strand inside of CRISPR, and it would go, find the DNA set, splice it, replace it, and that embryo, once fertilized and implanted, would then grow up into a child that would not have muscular dystrophy. And now, the problems that I see with this is that one, it has hazard to the embryo's safety, could cause social and economic gaps, as well as unintended side effects that it could have to the genome. And so with hazards to the embryo's safety, we have that it can cause on-target deletions as well as off-target deletions. And so Mark Thomas in his 2019 paper, Collateral Damage in CRISPR Genome Editing, which was published in PLOS Genetics, he stated that about 1 in 10 edited embryos resulted in a large on-target deletion. So now what that necessarily means is that it went to where it was supposed to, but it deleted too much. And so now that embryo would have so it could cure its, let's say, muscular dystrophy, but then it could have other mental illnesses as well as other genetic disorders. So you solve one thing, and now you have 5 things wrong with it. And so now if we refer down to this model, it shows the amount of transfers of embryos that it has occurred since 2004 to 2013, and you can see that it's gone down from about 3 to 2 since 2004. And now if we look at this next one, we can see that with each transfer, it is an increase of success in a pregnancy. And now while this is a good thing, you take out so many embryos for each implant, and so with each go, you take out about 4. And so if you're only using 2, or maybe even 1, you're wasting 3 embryos. So that is a waste of human life, some could argue. Now, my second issue would be with social and economic gaps. Now this is a picture just to show the rich being above the poor, showing a gap. And so with this, Jayashri Das made a great point in her paper, Redesigning Nature to Be or Not to Be, which was published in 2017 in Current Science. She said that with the cost of CRISPR being so high, only the rich will be able to use it, causing the rich to be genetically engineered to be successful. And now, with using CRISPR to edit genetic traits and not diseases and traits you cannot necessarily see, certain traits could be favored, such as gender. So we could have problems such as the China one-child law, to where they would rather have a boy since they can work in fields and such as that. Or they could prefer, let's say, blonde hair, blue eyes over any other kind of combination. So let's say, and if you didn't have blonde hair, blue eyes, you could be discriminated against because most people are engineering their child to have blonde hair, blue eyes. And now my third issue would be unintended side effects that could come to the genome. Now what that means is CRISPR could go in and do everything right. It targeted the strand, deleted it, replaced it, and that child would grow up to have whatever it had previously cured. Now, Christopher Gingal's 2017 paper, The Ethics of Germline Editing, which was published in the Journal of Applied Philosophy, he stated that the CCR5 gene, which codes for your white blood cell receptors, could be edited so that it makes the embryo resistant to HIV. Now, the problem that occurs with that is that, while it could be resistant to HIV, it is now more susceptible to other viruses such as like the common cold or basically any other kind of infection. So if we look to this picture here, on the right shows a white blood cell with the CCR5 gene, which would be these receptors here. And we can see the HIV hooking onto it and see that's how you contract it. Now, if we were to edit that CCR5 gene, you would see that the white blood cells no longer have those receptors, therefore the HIV can no longer take hold. But that is a problem because then it could affect the way the receptors detect other kinds of chemosyntheses such as viruses. Now, the solutions I have to these problems, so for the hazard and the safety, I would suggest that we make it so CRISPR is a 100%, like it will work guaranteed every time, and so it also will help to eliminate the waste of embryos. So once we get to the point where we know it'll work, we know it'll go in and do exactly what we want it to do, I say we shouldn't be able to use it. To solve the economic gaps problem, I would suggest we use is a very clear defined list of what it can do and what you can edit. So if it had anything to do with physical traits, I would say no, and also there has to be treatment and not enhancement. That's a huge argument, is that people will want to enhance a embryo and not just treat an embryo. So the same technology that could cure muscular dystrophy could enhance muscle mass in a normal embryo, let's say. And my final solution for the unintended side effects would just require a lot of research, is that before we can edit a certain gene code, we need to make sure that that gene code won't have any side effects that we are not ready to handle. So with the CCR5, for instance, we need to make sure that once we edit it, there's going to be no side effects that could potentially harm the embryo later in life. And especially since it's a germline edit, that will now be passed on to his offspring. So it basically creates a generation of people that could easily get sick. And so now I prompt you to research this and to see the benefits, see the cons, and to really educate yourself, because that's the only way that we can prevent any side effects and any unintended consequences of CRISPR, and to altogether create a better future for everybody.